So today we are going to learn about risk measures. So we are actually going to focus on 5 risk measures. I wrote 4 here. So variance, semi-variance, shortfall probability, value at risk, and conditional VAR, conditional value at risk. So I am not going to take a lot of time on the first 2 because I believe that you already know them. And then this one is also not that difficult, but then I have to go through them because again, because everyone has their own different need on the subject. So anyway, the first risk measure we are going to learn about is variance of return, right? It's variance. So in our case, we are going to learn risk. Again, we are going to learn about risk of returns. So so we are mostly going to focus on the variance of returns, right? So the utility that you have to use, or a person whose utility you can calculate returns for, it's actually a person who is risk averse. I mean, like, he's actually a person who has a quadratic utility, not necessarily risk averse, right? If they do ask, you should remember that you are actually, again, you can use variance to calculate a risk measure for a person who has a quadratic utility, but they almost never ask this question. But then if they do, you should remember that. So you should remember that you have actually proved that Markowitz model is again, so Markowitz model, which is minimizing variance, is the same as maximizing utility, quadratic utility. So this is where you're, again, so this is where this idea come from. So anyway, to calculate variance, I'm just gonna write the formula down. You have been doing this since first year, or maybe since from high school. So this one is for continuous. For discrete, right? So so this is the formula you are going to use. So as you can see, there's a problem with this calculation, right? The problem is that it looks at risk from all aspects. It looks at risk from again, it looks at risk. Okay, so okay, let's say maybe this is your returns, right? So this is your mean returns. Let's say maybe your mean. Okay, let's say this one is 0, and let's say this is your mean, and it looks at the return from everywhere. Whether it's go there, go there, go there, go like everywhere. So it looks at the volatility from all points. But then we are mostly not concerned about the. We are mostly not concerned about this kind of volatility, the one on top. We are actually concerned about the one under, right? So this is when we introduce an idea of semi-variance. So so for semi-variance, the equation for semi-variance is gonna be the integration, where x is gonna be less than x bar, right? X minus x bar squared f of x dx, right? So this one is for continuous. So continuous random variable x, and then if your returns are discrete, you are going to use this formula. It's the same thing, but then the difference is that you are actually looking at the returns below variance. So again, and then another thing you should take into consideration is that when you have a normal distribution or any distribution where there is symmetry around the mean, something like this. Okay, so if you have normal distribution, maybe, so it's simply mean that this side is the same as this side. So to calculate variance, semi-variance, you can just say 1/2 variance, right? So this will be semi-variance if there is symmetry, right? So anyway, I am gonna move on. So there's a person whose name is a student. Do you mind telling me your name? Because I have to take the register. So anyway, the other probability we can look on. Okay, so this one again has a problem. And what is the problem with this one? This one is that it looks at the risk below the mean, right? It looks at the risk below the mean, right? Below the mean. And sometimes we will need to make our own benchmark. So we are not necessarily looking at the mean, but then we can be saying below zero, like what is the probability or what is the risk of getting returns below zero. So this is when we introduce an idea of shortfall probability. So this one you measure returns, or actually you measure again, a probability of return that fall below a certain benchmark, and our benchmark is going to be zero. So to find this one, again, it will depend on whether he is continuous or not, from negative infinity to L. F of x, for since it's continuous, it's going to be f of x, the x, and then you find the probability. And then you're going to have x minus L for discrete. It's going to be the probability there. So continuous, discrete. I hope there is no question for this ones, because you can pretty much understand them. Any questions, though? I have to ask, is there any question before we can move on? If you don't have any question, you can say no, so that we can interact. I know what is the moods. Okay, thank you, John. So anyway, because I didn't want to take a lot of time on this one, I will move on to questions, right? So do I have any other questions? Okay, I think I should rather stick to questions from last year, from 2019 and 2020. Was there any question from 2020? Yes, there. Okay, so we can do this question together. So this one come from 2019 exam. I can give you a minute to try it or to think about it, and then we can make it through to get it together. There's someone whose name is student 5. Do you mind saying your name so that I know who you are? Okay, so I think you should have worked through this thing already. So anyway, the question says that an investor hold an asset that produces a rate of return of P runs over 1 year period. It is assumed that P has a log normal distribution. Log normal distribution random variable with mu 6% and sigma 6% squared. Calculate the shortfall probability. So as you will learn also in chapter, again, it's not actually a chapter, in stochastic interest rate, you actually went into detail that when you have something, if let's say maybe you have X and X is log normal distribution with mu and sigma squared, then ln of X is going to be again normal distribution with mu and sigma squared parameters. So now we know that our rate of return is going to be P, right? So they want you to calculate the shortfall probability where the return will fall below 1%. So basically, you will see that you're calculating the probability where P is going to be P will be less than 1%. So how will you find this, right? You already know that if you say ln of P, you can have ln 1%, right? And then from here, you will say P, and then you standardize this thing. You will have Z gonna be less than ln of 1% minus 6%, 6% over 6%, right? And then this will be your answer. Your answer is gonna be oh, actually, again, don't put the percentage here. Okay, don't put the percentage. Just put the 1 because it's going to change this answer dramatically very much. So my advice is that don't put percentage when you're using your logarithms. So and then you're going to have minus 1, and then you're going to look from your z-score, and then you're going to find your answer. Again from your table. So I assume that all of you can find the answer from a table. So are we happy now? Do you have any question regarding this thing we have done? So you can expect your question to be something like this in the test. I mean, like in the exam, because they wanna, spice it a little bit. Any questions? How do we know we have to put the percentage? So actually, my advice to you is that when you are so when you are using log normal, don't put the percentage sign. That's my advice to you, because the answer will be ridiculous. So I don't know why it changes that way, but then it does change that way. So it's just a tip from my side. I don't know how else can I explain it. But then even if you use percentage, you will see that your answer is going to be ridiculously high or low. In that case, you will have to go back and use just the numbers and no percentage. You don't use 0.001. But is the risk measure calculated should be in percentage? but is risk measures calculation should be in percentage? Yes. So this one again, they are looking at the returns, right? So they see that the returns. So remember that P is the returns, right? So whether you write 1% or just one, you already know that P is in percentage. So, but its risk measure calculation should we use percentage? But in risk measures calculation, should we use risk percentage? I am not sure if I have answered your question, but then P is the returns, and again. So let's say maybe you have X, which is returns, right? Which is returns, and is normally distributed, right? With mu percent and sigma percent squared, right? And then you can so to find the calculation for for X. So when you standardize this, and then you have something like this, you have X percent minus mu percent over sigma percentage. This answer should be the same as whether you have X minus mu and sigma, right? So here is because we are not using logarithms, so they won't have an influence on the values. So remember that logarithm of 0,001 is going to be ridiculously low. It's going to be an answer very closer to zero, very close to zero. So my advice is that don't use the percentage only when you are working with the logarithms. Only when you are working with the logarithms. Even in risk measures, when they tell you that something's going to be log normal, try to avoid using 0,01 to represent 1%. Just write 1% or 2%, or just write 2 for 2%, 5 for 5% instead. Any more questions? I'm not sure if I have answered your question. Any more questions? Or is there someone who wants me to repeat this thing, or you are all fine? Okay, good. So I am going to move on to the next question. So the next question is from last year's exam. So I would also love to give you a minute to have a head start, so that you can read this thing, and then we can work it out together. Anurup, did you have a question? Well, okay, so we're gonna start now. So this question you can see has 1 mark, so it's not that difficult. So question says that consider a zero coupon bond that promises to pay 7% for the next period. Suppose that they are, again, there's a 12% chance that the company will default on the bond, in which case there is an equal probability or equal chance of receiving 5% and 0%. Show that the expected return of the bond is going to be 6.46. So I can draw this thing. You have 88% chances, 88%. I can just say 0.88 chances of receiving your 7%, right? You are going to either receive 7%, or there's a 12% chances that this company will default, right? Default. And if this company default, then you have an equal probability or equal chance of receiving 5% and 0%, right? So in other words, if you want to simplify this, my advice is that you can simplify it. Ruth. Oh, okay, thank you. So my advice is that you should try to simplify this as much as possible. And then you can with 0.88, so that is 88% chances. And then you will have 5%. So 5%, you're gonna receive 5% with, so this one's gonna be 0.5 and 0.5. So you are going to receive 5%, again with 12% times 50%, and this is equals to 6% with 0.6%, 0.06 chances. And then you are also going to receive 0 with 0.06% chances. So this is for simplification, right? This is simplified. So if this is the case, you can find the returns. Now you can just say that the returns is going to be just going to be return is going to be the sum of the return, and the probabilities. So it's going to be 7% times 0.8, 5%, 0.06, and 0%, 0.06. Then your answer should be 6.46. Any questions? I hope this makes sense. So we're gonna move on to the next question. So the next question say that calculate the value of the following risk measures for investment rate. So you will have to find downside semi-variance, right? Semi-variance. So this is what they are asking you, right? So semi-variance is you will have to calculate variance below the mean, right? And the formula, since it's discrete, it's gonna be x less than x bar for x minus x bar squared times their probability. And then your answer is gonna be what it's gonna be. So again, so you're gonna have 5%, 0.05 minus 0.0. Actually, I can just write 5% instead. I will just say 5 minus 6.46 squared times the probability is going to be 0.06 plus 0% minus 6.46 squared 0.06, and then you find your answer over here, and then you write your answer. So and then we move further. The question saying that calculate shortfall probability, shortfall probability based on the risk-free rate of return. So we know that the risk-free rate of return is going to be 6%. This is what they are saying. And the expected shortfall below the risk-free return conditional and shortfall occurrence. So first of all, you will need to find a shortfall probability, which is going to be the probability that your returns, in this case, is going to be P, or I used X. I think I've been using X. X is going to be less than 6%, right? In this case, 5% and 0% are below 6%, right? And then again, you have 3 returns, 7 when you when the company does not default, and then you have 0 and 6 when they 0 and 5 when the company default. So your answer is going to be for 5%. So 5% has a 0.06% of a carry, and then 0.06% for 0% to okay. So it simply means that your answer is going to be 0.12. So this will be your shortfall probability. So, there's another question. It says that calculate the shortfall probability, the conditional in your expected shortfall. So this one we will do it after we have learned about conditional var, because expected shortfall fall under conditional var. But then if we have to, we can work it. So we can say that expected shortfall, right? Expected shortfall, the answer is going to be like this. So you are going to have the expectation, right, of your return of L minus X, right, of L minus X. So basically this is it. Or you can say that given the expectation, given that X is going to be less than L, right? So this is your conditional expectation. So in terms of writing this wave formula, you will say the sum of X less than L, L minus X times the probability. So this is actually the equation for expected shortfall. So to answer your question, so our benchmark still is 6% because that's how much they told us. So the benchmark is going to be 6%, like they have asked. So you can see that 6 minus 5, 5% has a 0.06% of a carry, and then you have 6 minus 0, and 0 has again 6% chances of a carry, and then you're going to find your answer. So it's just going to be 0.06. I think, no, he's not going to be 0.06, but then it's going to be an answer. So you can find this answers over here. Any questions? Is there any question I should repeat? Or I can move on to the next one. Wow. You can unmute your mic. You can write it down there. So anyway, I'm gonna end this session. Please rejoin now because Zoom will log us out automatically. So I am going to close it so that we can rejoin.